Let's continue with the final presentation. I want to welcome OpenBIM ambassador or OpenBIM, as I see, OpenBIM missionary, Leif Granholm from Trimble Solutions. So please welcome. And he's talking about data-driven workflows.
Okay, thank you. Yes, I was really happy to notice the previous presentation that that project had implemented my ideas of how the workflow should go about exactly. So this is going to be a very nice presentation to make after that. So as the emeritus BIM ambassador that I am, I always take the opportunity to specify my position statement of what BIM is. I have worked in the software industry for 44 years now. I'm retired now, but still I was hired by Trimble to come here and make a presentation, and still occasionally work some work. I have worked about half my career with location data, geospatial, and half with BIM, and let's say all my professional career I have worked with model-based data. I will explain a bit more what I mean with model-based further on. So for me, BIM is just a simple thing. It's nothing complicated, it's not processes, not anything special. It's just a technology. It's a new technology which is replacing an old technology. And the old technology BIM is replacing is printers, printing machines. Because now in BIM, it's just a transition from human readable documents to machine readable data, period, nothing else. That's just a simple thing. Beforehand, printers were used to distribute information in the construction industry. In the future, it will be data, and specifically machine-readable data. So, this has one of the biggest implications of this is that in the document world, human-readable document world, the content and the presentation of data were bundled. You couldn't unbundle them. The one who created the content also created the presentation, and you couldn't change the presentation. But now with machine-readable data, the content and the presentation are totally separated. So the consumer of data can choose any presentation he likes for the data by selecting some software which can present the data for him in the form he wants to have. And this in itself just is a huge change in how the whole industry works and how it can work. And of course, when it's machine readable, it can be processed automatically and even drive machines automatically, drive fabrication, drive earth-moving machinery, whatever. So it's a huge step forward in the usability of information, how we can use information. You don't need a human being always in between. You can do things automatically on the information which you get. So if I want to specify one thing I want you to remember from this presentation, so it's about this, it's not this. So this is what many people think that we should have, a single source of truth. It sounds nice, it sounds plausible, it sounds useful, it sounds, good. But for me, not possible. That's what I would call dream BIM. That we have a dream that everything is in a single database and everything is in a single model, but that's not just possible. Not with definitely not with current technology, and probably not with foreseeable future technology. So we have to do things differently, because this is what people want but can't have. And this is now the explanation of what we need to do, because we need to think in smaller pieces. So the basic thing is that for different tasks and purposes and things we do, we need different representations of the exactly same physical thing. And as an example, I usually use a slab in a building. So an architect, one object; for the engineer, 5, 10, 20 objects which are structurally functional, and for the detailer, 10,000 objects. And it's the same thing. And a detailer can't do his thing with an architect object and vice versa. An architect can do his thing with the detailed objects. You need these different representations, and they need to be throughout the life cycle of the structure. You need all of these representations. So you need multi-thing. And this comes from kind of basic philosophical and modeling theory, because of that the world is so complex, we can't model it completely. We have to base our modeling on abstractions. And built into the abstraction concept is that it's for a purpose. You don't have an abstraction which is just general purpose on which you can do whatever. So models are based on abstractions. And with what I do, I mean with model. Because that's, Anne already touched this, that the terminology is quite difficult. So when I talk about model-based, what I mean is that traditionally in IT, when you started to create the internal representation, the data, which would describe your problem and what you want to do, you did it from papers. You did it from documents. You looked how things had been abstracted on paper. And then you digitalize that. You built your application based on the paper representations of reality. When I say model-based, we do it the other way around. So when we start to design our internals of a model, IFC, whatever internals of an application, you go to the real world. And you see what is in the real world, and you create your representations on the terms of digital processing. Not how you can represent it on paper, but you do it directly for the digital processing. And then after the processing comes the representation, the kind of presentations of that data. And that's a big change. And we are lucky in the BIM community that IFC has been done that way. Whereas if you look at the geospatial, GML, City GML, the other one, they are done in the traditional way. You take the map, you see features there, and then you tell that this feature now is an object, but it describes the map feature, not the real world feature. So in that way, BIM has been lucky that BIM has been a bit after geospatial, because BIM has done the things right from the beginning. But to appreciate, because this also makes a bigger change in one go than if you go from paper to digital paper to model. It's a bigger change in one jump when you go from a kind of real world to directly to a digital representation, disregarding on how is that going to be presented on paper. You do it on the terms of processing and what you are going to do with the data. But that's a very important thing to do, to remember. And it's to understand how the BIM and machine-readable data and modeling work, it's important to understand the fundamentals of representation, because all of this, when we deal with data, it's all about representation. We represent something else with data. And that's a very important detail to model. Then a bit about the BIM concept, how we are using how are we going to use this technology to drive construction processes. And I have kind of invented this term, productivity BIM. Because now there is a risk that, and it's happening already, that people are experiencing BIM as a burden, because the main focus in BIM now has recently been for collaboration. You think that you do BIM mostly for collaboration with others. And I say that's wrong. Your primary motivation to do modeling and do design, do analysis, should be to make your own work more productive, to make your own work better, to make the result of your work better. And I could call it selfish BIM, but I think this productivity BIM is nicer. But, and then the collaboration should come mostly as collateral damage, so that others can use information which you have created for your own purposes. Other people can use that. And the rest of my presentation, I will focus on how that can be done and how it should be done in real. And the kind of name for the concept on how that should be done is federation and publishing based open BIM information architecture. And that means that we don't try to cram everything in one model. We create purpose specific, you could call them sub-models, data sets, whatever, there isn't a kind of established term. In the geospatial community, data set is an established term. In the if you say to GIS or geospatial people data set, they immediately understand what you mean. It's a subset of data for some specific purpose. And that could maybe be better. But the main principles of this is that you split your application so that you have your own data which you own, which you create, which you manage, which is yours, and then you have data which you have gotten from others. This collateral damage I was talking about, you keep them separate. You never mix them. You keep them totally separate, and you have a firewall between them, and the publish-based here means that you never change something which you have gotten from others. So it's a very traditional publish concept there, that you give data out and then that's fixed. If you want to change that, you make a new version and give a new version and keep track of those. And there's good technology now to do digital signature so that you can really trust that this is the original data which the publisher of the data intended it to be. So that's why if somebody says to me that, oh, it's good to edit IFCs, I say, no. We don't want to go to that same situation we had with Word documents, that you have documents with the same name floating around, but we have different content. We don't want that, because to really make the digital workflow, we need trust. And trust is built by this publishing thing, so that you can verify that this hasn't been changed. This is the original data. And if we don't have trust in the data we exchange between parties, the digital workflow won't happen. So trust is a very important part, and trust we get with this publish concept. Then if we look at more what we need for this workflow to happen, so we have two main topics to consider, again about trust to a large. We have content creation. How do we create the content? Capturing requirements, designing, planning, production, fabrication, operation, maintenance, even down to renovations and recycling. So the whole life cycle of anything we design, be it buildings or bridges or whatever infrastructure. And then we have information management. This is all about the trust. So we need provenance. We need to know who has designed it. Is this available? Access, intellectual property rights, schemas, formats, digital signing, all of this. And we need all of these things to achieve that trusted situation which we need. Then a bit about how I envisage that content creation happens in this, because I said earlier there that this concept also fulfills the BIM's original promise, that you don't have to enter data twice. You don't have to re-enter the same data again and again in different systems. So this is how it works. You take that data, so the architect has given the slab, now a same example, to the structural engineer. And structural engineer has an application which is specifically a structural engineering application. It can take the architect's slab and help the structural engineer semi-automatically or fully automatically, or mostly manual, to create his own representation of that slab, which is the structurally functional parts of that slab. And the idea here is that you have an application which is not just human controlled. You have application which can understand incoming data, can use incoming data automatically, maybe present it to the user, maybe do something automatically with it. But the point here is understand, so that your application, it doesn't just take it to present to humans, it can do things based on the incoming data automatically. That's the big point, and this is what will give more productivity and effectivity to the workflow that we can do. One of my kind of executive summaries of BIM is that BIM is all about automating reception of data. Whereas traditional BIM have been mostly about creating data. But that's changing now. If you look at the exhibition down there, 70–80% of the applications are already for data consumption, for using data. So that's a big deal with BIM. And we can also, I'm coming more to the linkings later, we can automatically create links so that the engineer objects knows which architect's object it's dependent on, and vice versa. The architect object can know which engineering and other objects are dependent on that object. So the architect can kind of estimate that if I change this slab now, what will happen? So this will work throughout the project. Then a few words about open software, and I was pleased, this is kind of exactly what the previous presentation project had done. So this concept enables that and promotes that we have more purpose-specific applications. Applications which are created just for one purpose, not kind of these 500-button applications that you have these huge BIM applications which are for whatever BIM. So my mission is to promote this idea that we will have smaller. Instead of 500 buttons, we should have 5 buttons in the application, and the application should really deeply understand what you are doing. So use case specific applications and deliver that original promise that you don't have to re-enter data twice. So this is a kind of a picture. Instead of having this multi-purpose tool with all kind of stuff, you have a more for the task specific tool to do your job. Then also capturing data in all phases is a very important part. So by using these smaller purpose-specific applications, a big part or big chunk of that capturing is automatic, because the result what you do captures all the phases, all the things, all the decisions that have been made, and can have all this provenance information built in and the responsibilities, and this again builds trust. But then, of course, we also need to capture what's built and other things, and this concept also makes kind of the new data capturing applications much more feasible to enter into the ecosystem of data that we are building up and having in the construction industry. Then a few words about information management. So publishing snapshots of partial models, databases, that's very simple and reliable to do. It's verifiable and builds again that trust. And of course this way is compliant with the existing CDE infrastructure and ISO 19650 series of standards. And we already have the existing and well-tested technologies to do this. So to do it in this way, we don't need any new inventions, so we can focus on building these new purpose-specific applications. By the way, until now, about 80% of BIM applications have been all about creating data and 20% to consume, and that will reverse, at least reverse. It has almost reversed already, so 80% will be about the consumption of data and 20% just specifically for creating data. And this also enables the consumption data, that you get a lot of the capturing of what has happened in the project automatic. When you do the data consumption through the application, you can capture also the data, what has happened there. Then information management, IPR issues. The nice thing with this is when you publish snapshots of the data, you don't publish the parametric intelligent models, because they are not just static data parameters, they are code, program, intelligence, which can react to changes. And you don't publish because you don't need later on. And if we look at archiving, if you do, for instance, renovations or whatever, the parametricity you have in the initial project phase is not going to be useful in the renovation phase anyway, because you don't do the same things to the structure or model in the renovation phase or in the operation phase than what you do in the design phase. So the parametricity is wrong for the later life cycles. The parametricity usually in the design models is for designing, how to react to design changes. But you don't do that kind of things. And people say that IFC is difficult to edit. Well, I have a good contrary to that. That concrete is much more harder to edit than the IFC representation of it. So that's not an issue. And also the IPRs are exactly the same for the snapshot than they are for drawings. No difference whatsoever. You just the IPRs are exactly the same. You regulate in the same way how you can use that content. And that's the natural way to publish is open BIM formats, IFC, GML, and other schemas, and that's very crucial for archiving, for instance, because if you can't really archive the native, active native models because they don't live. If you try to open a 5-year-old model of almost any big BIM software, you take Revit, Tekla Structures, Bentley or whatever, it won't open. So if you want to keep your archive alive, which you have created with native models, you have to open them with every major release of that software. Every model has to be open, converted, and stated. And conversions are evil is one of my mottos. So if you have done to your archiving model 10, 20 conversions, how many errors are there? Many. I'm sure of that, because conversions are hard to do, and conversions are evil is my kind of, I try to avoid, and this concept minimizes conversion. So you always have to do this conversion from the native representation to the publishing representation. But then the other way, you don't convert. You use it directly in the standard schema. That gives this provenance again, and also reliability, because if you have several conversions in a row, and when you find, not if, when you find errors, those are very hard to track and find, virtually impossible if you have gone over many conversions. Well, does it sound like a big mess? At first sight, it might do that. This is a huge mess. That how can we, many applications used by different parties for different purposes, multiple CDEs in the same project, that's happening already. Sensors with different hardware producing data, drones, all kind of stuff. And for that, we need a backbone of some sort. And there is a solution. It builds on standard web technologies, HTTP, very familiar technologies, readers, and part of this vision is for the internet to become a big global database, a distributed database for your BIM data, geospatial data, whatever data. It's called Web of Data. And the solution is drumbeat. Next, linked data. The solution is called linked data or semantic web, or there are, dear baby has many names, so, but linked data is what I'm talking about. And the main principles of the linked data are not new. So this was Tim Berners-Lee is the guy who invented the World Wide Web originally, and already in 2006 he started to develop and came out with a foundational paper for the linked data concept. And it builds, there are a few central concepts, core concepts in this technology. That linked data is a technology, you can call it. And URIs is the most central to them. And at URI, it's Unified Resource Identifier, and it's a pretty simple thing, because that's nothing else, nothing more than a combination of address, internet address, HTTP something, and a GUID. And both we have. That's very well specified, and both are existing technology. And this is also called Web of Data in the kind of general data processing world. And the foundational idea of this was already to make the web machine readable. So same idea than with BIM. We have to make web machine readable so that we can automatically process and further enhance, amend, do things with the data on the web. Because HTML was just human readable stuff so that you could present it, and the kind of presentation, it has been kind of separated with the style sheets. You can do a little bit of formatting for the text, but not much. So what this semantic web linked data technology brings onto the table is that you can have, apart from this simple formatting, you can have also the semantics included in the data you publish on the web and make it truly and really machine readable. And the useful information should be identified in the names, and these links which I'm talking about, which is the kind of central concept in linked data, they are typed and they are called triplets. So you always have two URIs. You have two things you point to, and then you have a type and semantics and attributes on that link. So the fundamental structure is quite simple. One of them, if we look at how this could be used in OpenBIM, the interesting point here architecturally, and I talk a lot about information architecture, and this is a very crucial point for the information architecture, that these links do not need to be embedded with the data. They can be separate from the data. Exactly as we can separate the content of presentation, now with this we can separate content and relationships. What kind of relationships our data has to other days, they are separated. You can create these link sets separately, totally from the data, and publish just the link set. So one of my visions here has been that in the future, a quote could be just a link set. So you have, this is the requirement object, this is the implementation object, and this is the price and commercial terms. So this would be a very, very useful thing to use in BIM. And those links can be used actually not just on two, they can be used on 3 levels. So you can have type links, you can link types or classifications. You can link classifications with each other, you can link data sets with each other, and you can link individual objects within data sets with these links, so they are very flexible. And these links make it possible to traverse the data if we take this phase dependent, that you have many representations. So you can go upstream or downstream and find what if I need to change this, some party in the project needs to make a change. So with these links, they can traverse, they can go upstream and see what will this change affect, and they can go downstream and see what will this cause. Or let's say upstream, it's that it requires changes, and downstream it means that other people have to change their stuff to accommodate my change. And that would make the kind of changing and these RFIs, request for informations, you could automate those and do that. And actually, if you know this BIM collaboration format, BCF, that was originally, I was one of the original designers of BCF, and it's designed exactly for this purpose, so that you can machine readably transmit those change requests. So we have been working at this for quite a while already. This also one interesting thing about the linked data concept and the whole technology is that it takes away the firewall between the data specification and the data instance, the instance of data. Because traditionally you have had so that the schema is it's something separate somewhere else, stored in a different way, and then you have instances of like IFC, you have the IFC specification on the Building Smart website, and then you have the IFC files which you create, which follow that specification. But this semantic web technology takes it one step further, that if you like, you can have them in the same data set because they are expressed in the same language. It's called RDF, Resource Description Framework. And there you can have in the same, both the schema and the data instance are represented as in the same format. So you can actually separate those. So this gives the possibility to make graphs. You can have graphical representation of things. This is an example how this kind of graph networks could work in a BIM concept. And also for digital twins, you can use this concept to build. I don't like the term digital twins because as we saw in the previous presentation, there were 5 twins. What kind of twins is that? So I would call them digital services, just different kind, for different purposes we need different services. And with this you can do, this service probably needs a native model for its own and have native objects, which can be based on external objects, and then it can take incoming all kinds of data and take that in real time. Maybe cached locally, but only as a cache, not as something you have editable and usable. So this concept also works. It works in all life cycle phases of any kind of project or structure. And the software needs to evolve so that we have more automation, less human interaction. Today, most of the BIM software does what the human tells it to do. The softwares need to be capable to do more automatically based on the data input, and so data-driven software architecture. And my kind of mission and vision why I'm doing this is that I want to leverage the role of open standards, that should be the normal way of consuming data. Like for textual data, PDF is the normal way to distribute and consume textual data today. The same should be with IFC. So the normal way, and not just to publish it, but also to consume it, so that your software should be able to understand IFC directly without conversion, without human intervention, so that it can present the data content to you exactly in the way that you want to have it. And we have had several research projects in Finland funded, and actually there is an IFC OWL, which is the semantic version of IFC. We have funded the development of that to a large extent within these projects. So in the slides you can still find these links. Those projects went on for almost 10 years ago, but we have had new projects until recently. But that was all. Thank you.
Thank you, Leif. A short question if somebody has a question.
I have one, yeah. Thanks, Leif, for the presentation. Thank you very much. You touched the subject of IPRs. You've been brave. Could you elaborate a little bit on a situation whereby, for example, an infrastructure owner issues a tender, he requests that the general contractor provides BIM models as a result of, for example, say I am a manufacturer of ventilation systems, yeah, and I need to provide through the tender, I need to provide a BIM model that contains those objects that will be representing the different components of the ventilation systems. But those objects are modeled in a library that I own. What do I do with the ownership of those objects that will be then transferred over to the owner and that can be spread all over the world, possibly?
Well, it's no different than if you have symbols on a drawing. Same thing. It doesn't need to be more complicated than that. Because if you have your own symbol library and you put those symbols on the drawing, but because also, of course, when you put the components in an IFC model, they will be stripped of all intelligence in the IFC instance. So they are not reusable in the same way than a component would be in a Revit or Bentley or AutoCAD model. It's a snapshot also of the component. And that makes it that it's totally analog with that you have on paper a symbol. Of course, it's up to the course. It will probably be up to the course to decide it somehow. But at least from the technical point of view, technological point of view, no difference if you get something on paper or a digital snapshot.
Okay, thank you, Leif. And end of the session, and next you have a